Welcome to 1000 Why Questions. Here we dig into everyday mysteries you've always wondered about. You've stepped outside on a sunny morning, looked up and thought, wow, that blue is perfect. But then you wonder, why blue? Why not green, purple, or pink? The sky seems like it's painted that way for a reason. But what's actually happening above us? From beaches to highways, that same blue dome follows us everywhere. Airplanes slice through it, sunsets painted orange, yet midday always glows bright blue. We never question it because it feels normal. But the reason hides in something smaller than dust. Sunlight itself. Sunlight looks white, right? But it's actually made of every color. Red, orange, yellow, green, blue, indigo, violet, all blended together. When sunlight hits the air, those colors start to split apart. What's strange is, our eyes don't catch them equally. Imagine shining a flashlight through fog. The light scatters in all directions, making a soft halo. The same thing happens when sunlight passes through Earth's atmosphere, except instead of fog. It's tiny air molecules bouncing that light around like invisible billiard balls. So here's our big question. Why does that scattering make the sky blue? What's so special about blue light that the universe decided to show it off all day long? To find out, we need to peek inside how sunlight and air really interact. Here's what's going on. Sunlight enters the atmosphere and hits air molecules, mostly nitrogen and oxygen. These particles are much smaller than the light's wavelength. When light waves hit them, shorter wavelengths like blue and violet scatter way more than longer ones like red or orange. Think of red light as a slow, long surfer wave. It rolls past big obstacles smoothly. Blue light, though, is choppy and short. It crashes into everything. That's why it bounces around the sky hundreds of times before reaching your eyes, while red light mostly passes through. This constant bouncing is called Rayleigh scattering, named after Lord Rayleigh, a British scientist who figured it out in the 1800s. He realized that the smaller the particle, the more it scatters shorter light. It's the same principle behind why sunsets turn red later. During the day, sunlight takes a short path through the atmosphere, so blue light dominates the view. Your eyes see millions of scattered blue photons from every direction at once, blending into that endless dome we call the sky. But at sunset, the light travels farther through the atmosphere. The blue light gets scattered out before reaching you, leaving only the longer reds and oranges behind. That's why sunsets glow fiery. It's just the leftovers of sunlight's long journey. So blue wins midday, red wins evening. But here's the twist. If blue and violet both scatter more than red, shouldn't the sky look purple? That's where human vision steps in and rewrites the story. Researchers at Harvard explain that our eyes have three kinds of color sensors, cones for red, green, and blue light. We're less sensitive to violet light, and our atmosphere absorbs most of it anyway, especially in the upper ozone layer. So even though violet light scatters more, we barely notice it. Blue dominates because it hits the sweet spot for both scattering strength and our eyes' sensitivity. It's like our vision and the atmosphere teamed up to color the sky. NASA scientists often describe sunlight as white paint through a filter. The filter, Earth's atmosphere, spreads the shorter wavelengths. That's why from space, where there's no air to scatter light, the sky looks pitch black even under full sunshine. The blue we see isn't a solid color. It's scattered light from every molecule above us. That means no two people ever see exactly the same shade of blue. It depends on air quality, humidity, and even your altitude. At higher altitudes, there's less air to scatter light, so the sky looks deeper and darker. That's why mountaintop skies or airplane windows show a more navy tone, while city air appears pale blue. The cleaner the air, the deeper the hue. Scientists also measure this color shift using something called aerosol optical depth. Basically, how much stuff floats in the air. The more particles, the less vivid the blue. Pollution dulls the sky because light gets scattered in every direction unevenly. So every blue sky is a snapshot of how clean or hazy the atmosphere is that day. In fact, some satellites can estimate air pollution just by analyzing how blue the planet looks from orbit. The science literally paints our sky's health. But here's the weird part. Blue skies don't look blue to everyone. Animals with different eyes see something totally different. Some birds and insects can detect ultraviolet light we can't even imagine. Bees, for example, see ultraviolet patterns in flowers under the same sunlight we see as plain blue. What looks like a simple daisy to us glows like a neon runway to them. Their blue is mixed with invisible wavelengths guiding them straight to nectar. That means the color of the sky is partly in your brain. Human vision filters wavelengths to build the color we recognize as blue. To another creature, the same light could look completely different, maybe more purple, maybe even invisible. It's wild to realize color isn't fixed, it's a translation. Your brain turns scattered light into meaning, using your eyes as sensors. So when we say the sky is blue, we're really describing how we process scattered sunlight, not how the sky truly is. And here's another twist. Astronauts on the International Space Station see no blue above them, just black space and the curved glow of Earth below. The blue disappears once you're above the air doing the scattering. From space, Earth's thin blue rim, the atmosphere, looks fragile and glowing, only a few miles thick. That glowing edge is what makes our skies possible. Without it, sunlight would just pass by, leaving our world in stark black and white. So that blue overhead is both an illusion and a gift, a side effect of light, air, and biology working perfectly together. Every time you look up, you're literally seeing sunlight broken apart, reshaped by our atmosphere and interpreted by your mind. To recap, sunlight hits air. Short blue wavelengths scatter the most. Violet gets absorbed and our eyes finish the job. The result? The planet's most recognizable color, the everyday blue sky. That blue tells stories about clean air, warm sunlight, and the chemistry keeping us alive. It's more than just a backdrop. It's a mirror of Earth's balance, shifting every minute with light and motion. Next time you catch yourself staring at the clouds, think about what you're really seeing. Scattered sunlight painting our world. That glow connects us with every creature under the same sky. Makes you wonder, if the sky's color depends on light, air, and eyes, what about the ocean's blue? Or why the moon sometimes turns red? There's always another why waiting just above the horizon. So why is the sky blue? Because sunlight, air, and biology dance together to create color we can see. If you enjoy small everyday science like this, stay curious. There's a whole universe hiding in plain sight. We hope you enjoyed this episode of 1000 Why Questions. Don't forget to like, subscribe, and share to support the channel. Got a thought or your own why question? Comment below. And if you want more,